Hello guys, welcome to my channel, and today I'm gonna share a LeetCode question number 1335, the minimum difficulty of a job schedule. And the description is we have to schedule a list of jobs in D-days. And the jobs are dependent, which means you have to finish the first job and then do the second job. And you have to finish the current job to do the next job, and you have to finish on the next job, then do the next job, right? So, and we have to finish at least one task every day. And the difficulty of a job schedule is the sum of difficulties of each day of the D days. And the difficulty of a day is the maximum difficulty of a job done in that day. So, so how can we solve this problem? And so the question asks us to just return the minimum value instead of finding the specific job schedule. So it is kind of a typical dynamic programming. And the key to a dynamic programming is first to find the state transition equation, and then the second to determine the initial values. So at first, let's just find out the so-called state transition equation. And when we solve algorithm questions, we generally start with the intuition. For example, brutal force is kind of intuition. And in this dynamic programming, we are asked to plan our job. So let's try to see from our intuition that if we can make a schedule. So the problem requires us to do at least one job a day. So each time we arrive at a new day, we can choose to do one job, or two jobs, or three jobs, and so on. And then by the next day, we can still choose to do one job, two jobs, or three jobs, and so on. So how can we choose? And the question asks us to choose the least difficulty combination of tasks each day. That is, we have to choose the least difficult combination among all the combinations. Well, this is our intuition. And each day has multiple choices, and all the days make many combinations. So we have to choose the best one from all the combinations. Okay, so let's use a table to show the process. Okay, here's a table, and we can see there are 5 rows and 3 columns. That means we have to do 5 jobs in 3 days. All right. So, okay, here's a question. What does each cell mean? What does each cell mean? Okay, it means the minimum difficulty to complete J jobs in I days. Okay, the first cell here is that means we just do one job in one day. All right, because just the first job and the first day. So we have to do one job in one day. And let's look down the next one. That means we have to do two jobs in one day. And this means we do three jobs in one day. And this we do four jobs in one day. And this means we do five jobs in one day. So what's the value of these five cells? Okay, so quite simple, right? In this first cell, the value will be the difficulty of job 1, and the second cell will be the max value amount between job 1 job 2, and the third cell here is the max value among job 1 to 3, and here is the max value in job 1 from 1 to job 4, and here's the max value from job 1 to job 5. So it's quite easy to understand, right? And I just use a different color to make it clear to see. And this yellow one, that means the first day we do the first job, and the red one, it means the first day we do two jobs, and the red, a green one, the purple, the black. So let's see the second column. In this column, what does this cell mean? That means impossible. That means we have to do one job in 2 days. That's impossible because we are asked to do at least one job in one day. So just one job in 2 days. So that's impossible. And we just set it to infinite. And what does this mean? This cell means we have to do two jobs in 2 days, right? So how many choices do we have? We have just only one choice. Just do the first job in day 1 and do the second job in day 2. So the first job in day 1, I use this yellow color. That means it's same as this one. So this part is this part, all right? And plus the value, just we do job 2 in day 2, all right? So let's look down the next cell. How about this one? This means we do 3 jobs in 2 days. 3 jobs in 2 days. And how many choices do we have? Okay, we may have 2 choices, right? The first is to do job 1 in day 1 and then do job 2 and 3 in day 2. And the second choice is we do job 1 and 2 in day 1 and plus do job 3 in day 2. All right? So this is this cell, right? I'm sorry. This is this cell, right? And just plus to do the rest jobs. And how about this one? It's just do 2 jobs in day 1 and kind of this cell, right? Do 2 jobs in day 1 and plus do the rest job, the third job in day 2. And let's look down the next cell. How about this one? That means we do 4 jobs in 2 days. So how many choices do we have? Okay, it's just kind of spend some time. I just explain the details of this process to show you guys how the process is. Yeah, right. So this means do 4 jobs in 2 days. So how many choices do we have? We just do job 1 in day 1, which is this cell, and plus the rest job. Do the rest job in day 2 and do 2 job in day 1, which is this cell, and plus the rest job in day 2, and do 3 job in day 1, which is this green, that means we do 3 jobs in day 1, right? And then plus we do the rest job in day 2. Okay, and this cell means we do 5 jobs in 2 days. And how many choices do we have? We have 4. Just do job 1 in day 1, and then do rest jobs. Do job 1, 2 in day 1, do the rest jobs. And job 1, 2, 3 in day 1, and do the rest jobs. And do job 1, 2, 3, 4, 1, 2, 3, 4 in day 1, and then do the last job in day 2. And the value of this cell is the minimum value of all these values. From all these values, the minimum value in these 4 values. Okay, so now is kind of getting clear, right? Now we can see how it works. And let's just see this column. It's quite easy, right? This is impossible because we cannot do 1 job in 3 days or 2 jobs in 3 days. At least we have to do at least 3 jobs in 3 days. So we start from here, just do 3 jobs in 3 days. That means we have no other choices but to just do 2 jobs in 2 days in 2 jobs in 2 days, and plus do 3 jobs in the 3rd day. So this is kind of the black one is this one. Do 2 jobs in 2 days, and then do the next. And this cell is about to do 4 jobs in 3 days. And how many choices do we have? So we can do 2 jobs in 2 days, and then do the rest jobs on the last day. And then okay, this black one is this cell, do 2 jobs in 2 days. And how about this blue one, is dark blue one, that do 3 jobs in 2 days, kind of this cell, right? So and then do the last job in the last day, which is the 4th job in the 3rd day. How about this last cell? Let's look. And this cell means we do the 5 jobs in 3 days, all right? And how many choices do we have? We just do 1 job in 2 days, 2 jobs in 2 days, 3 jobs 2 days, and 4 jobs 2 days, and then do the rest jobs, right? And the final value will be the minimum value of all these values, right? So this is a basic idea of how the process is. So let's see the code. Alright, let's just see the code. And the code is quite short. Okay, here's a job array, and here's the length of the job array, and here is a DP array, and we just initialize the 2D DP array with the just like the first column, right? It's quite easy to understand. And then we do the loops. There are 3 level loop, 3 loops here. And the first is a day, and then the job, and then what choices can you have? How many choices can you have on each day for each job? And here's the max, and we got the max value from the rest of jobs, right? But this time complexity is a little bit slow because inside this 3 level loop we need to get the maximum value among the rest jobs, on the last day here, and we got the max value, that it will take a lot of time. It will take a lot of extra time. But it seems we have no other choice because we just start job 1 and then job 2 and then job 3. And if we do them just one by one, and we don't know which job is the most difficult in the future, because the jobs are in the future. So we have to traverse all the rest jobs. And so in this case, how can we know which of the future jobs is the most difficult? So we can consider another way. That is, let's just imagine that we have a time machine and we travel it to the last job in the future. And then we look backwards. So here is a better one, and also 3 loops, but we just keep the max value from the last one to the first one, right? So we just loop backwards, just keep the only maximum value each time, and keep iterating backwards so that we can get the maximum value without iterating through all the rest of jobs each time. So this is a better solution than this one. So, okay, here's the explanation and solution for question 1335, and this is my first time to do this video, and thank you for watching.